Assalamualaikum and hi everyone. Today we will be discussing high voltage testing and precision-based maintenance or CBM for transformers. These practices are crucial for ensuring the safety, reliability and longevity of transformers. The purpose of CBM is to monitor the health of transformers, detecting early signs of failure and reduce unnecessary repairs or downtime. The benefits of CBM include lower cost, faster restoration of service, longer equipment life, preventing major failures or outages. By using high voltage testing, we can identify potential installation issues, ensuring the safe and reliable operation of the transformers.
Hi everyone, this slide covers the insulation power factor test, a key method for checking the health of transformer insulation. It works by measuring how much AC energy is lost. High loss can mean moisture contamination or insulation aging. We run this test on the windings, bushings, and oil. If we see a high power factor, it usually means there's a problem that needs attention. This test helps us find issues early and plan maintenance before anything fails. It's a simple but powerful way to keep transformer running reliably. Let's talk about bushing power factor testing. A bushing is the part that lets high voltage wires safely pass through grounded equipment like transformers. It needs to withstand both electrical stress and mechanical force. Inside the bushings, we measure two key capacitance. C1 is between the main conductor and the test tab, and C2 is between the test tab and the grounded plane. We do this test to check the condition of the vapor oil insulation inside. A high power factor tells us if there moisture contamination or deteriorations. The goal is to catch problems early and keep bushing working safely. That way, we avoid unplanned failures and keep the system reliable. Now let's look at the winding power factor test. This test checks if the paper insulation inside the transformer is still dry and in good shape. If there moisture or contamination, the insulation can break down faster. Moisture can come from several sources. Sometimes it's left over from the factory, especially in fixed insulation. Other times, leaks or poor sealing let air in. Over time, even normal aging of oil and insulation adds moisture to the system. When moisture is present, especially with heat, it forms acid inside the transformer. That acid weakens the insulation and causes it to fail more quickly, reducing the life of the transformer. This brings serious risk. The transformer may become overloaded and the insulation losses its reality strength, meaning it can handle voltage as well. All of this leads to faster aging and a higher chance of failure.
Another important test in the excitation current test. This test detects core defects, insulation failures, and issues with the tap changer. It works by measuring the current required to energize the transformer's core. If there are short circuits, the current increase due to lower resistance. The key indicator of potential issues is when there's a significant difference in current between the phase of a three-phase unit, particularly when one phase shows a lower current. This is the sample test to set up similar to power factor testing. Frequency dielectric spectroscopy or FDS is another valuable tool for assessing transformer health. FDS measures the moisture in the transformer's paper insulation and analyzes its dielectric behavior across different frequencies. This test helps detect insulation conditions and moisture level, which are vital for assessing the aging process of the insulation. Moisture, when combined with heat and oxygen, accelerates the breakdown of insulation, making tests crucial for early detection or degradation. Next, we have the transformer turns ratio test, which is used to verify the high voltage to low voltage winding ratio. This test helps identify shorted turns, wrong-tap position, or loose or faulty connections. It is performed during commissioning after major repairs or following a fault trip. By comparing the measured voltage ratios, which is expected values, this test ensures that the transformer functions correctly before being put into service. Now, let's talk about sweep frequency response analysis, or SFRA. SFRA is particularly useful for detecting mechanical damage such as winding, shift, or core movement, which can occur due to transport vibration, short circuits, or lightning strikes. The great thing about SFRA is there is none intrusive. There's no need to open the transformer to perform the test. By measuring the transformer's frequency response and comparing it with baseline data or similar units, SFRA allows us to detect hidden problems early. Another important test is the insulation resistance test, which checks the insulation between winding and the ground, as well as between different windings. We apply a DC voltage to measure the insulation resistance. Healthy insulation shows high resistance, usually measured in mega ohm. This test is vital for prevent short circuits, overheating, and transformer failure, especially after repairs, flood, or transport. Chemical tests like dissolved gas analysis (DGA) play a critical role in assessing transformer oil quality. DGA detects gases produced from insulation or oil breakdown, such as methane, acetylene, and ethylene, which can indicate faults like arcing and overheating. Other oil quality tests include measuring acidity, water content, and dielectric strength, all of which help assess the risk of insulation failure and oil contamination. Regular chemical testing ensures the transformer oil remains healthy and safe for use. To assess the insulating strength of transformer oil, we perform a breakdown voltage, which is BDV test. This test checks the oil resistance to electrical breakdown by applying its voltage across two electrodes until a spark occurs. The breakdown voltage is an indicator of the oil's health. Low BDV values suggest poor insulation and increased risk of failure. Healthy transformer oil should have a BDV greater than 30 kV. In conclusion, condition-based maintenance, CBM, and high voltage testing are essential for maintaining the reliability, safety, and longevity of transformers. By regularly conducting tests like the insulation power factor test, excitation current test, dielectric spectroscopy, and dissolved gas analysis, we can detect early signs of degradation, prioritize maintenance, and prevent catastrophic failures. This practice not only reduces downtime but also helps extend transformers' life and improve overall performance. Thank you.